What if you are given a series of complexes, of metal complexes, and you are asked to determine or to identify the number of unpaired electrons of a metal center in the compound? So here's why we measure magnetic susceptibility. So what is magnetic susceptibility? Magnetic susceptibility is a measurement of magnetic properties used to characterize a wide range of systems from oxygen, metallic alloys, solid-state materials, and coordination complexes containing metals. Magnetic susceptibility is the ratio of the intensity of magnetism induced in a substance to the magnetizing force or intensity of field. It is a degree of magnetization of a material in response to an applied magnetic field. If the magnetic susceptibility value is positive, the material can be paramagnetic, ferromagnetic, ferrimagnetic, or antiferromagnetic. However, if the measured magnetic susceptibility value is negative, the material is a diamagnetic material. Paramagnetic properties is given by at least one unpaired electron present in a metal center. At least one unpaired electron will give the positive magnetic susceptibility value. The more unpaired electrons is determined or is found in a metal center, the higher the magnetic susceptibility value. In this experiment, we are going to measure the magnetic susceptibility of manganese 3 acetylacetonate, and from there we'll calculate the number of unpaired electrons of manganese 3. So for synthesizing manganese 3 acetylacetonate, we're going to need 3.9 gram of manganese chloride tetrahydrate and 10.2 gram of sodium acetate trihydrate, where these two chemicals will be mixed together, and after that we'll add acetylacetone 18.8 ml slowly into the mixture. So this is what we're going to do. So what is stirring right now in front of you is 10 gram of sodium acetate in water, and we're going to pour a solution of manganese chloride tetrahydrate. Okay, so let the mixture stir, and after that we'll add 18.8 ml of acetylacetone. So we're going to use a dropper, okay, to add this really slowly into the mixture. All acetylacetone has been completely added into the mixture, and the mixture is currently stirring. A solution of potassium permanganate will be added into the stirring mixture. Before you start the experiment, you have to prepare 0.79 gram of potassium permanganate in around 38 ml of water. So add this solution slowly. We started with using manganese 2 chloride, and since we are going to prepare a manganese 3 complex, so we need to oxidize manganese 2 to manganese 3. The addition of potassium permanganate solution is finally completed, and after this we shall wait for a few minutes before we add another solution of sodium acetate trihydrate, but this time the addition has to be done in small amounts, just like when we add potassium permanganate. Dissolve 9.8 gram of sodium acetate trihydrate in about 40 ml of water. second sodium acetate trihydrate solution has been completely added. Heat this mixture on a water bath for 20 minutes at about 60 degrees C. You can see now we have actually started heating the mixture. Okay, and the mixture, the beaker is placed on the water bath, not heated directly on the hot plate. The heating for 20 minutes at 60 degrees C is almost done, and we're going to put this in the ice bath to obtain crystals of manganese 3 acetylacetonate. After cooling the sample in an ice bath, we shall filter off the dark solid, the dark compound, by using suction filtration. And after that, we will wash the product or rinse it with ice cold water. So you see, you may want to know, why do we rinse the product with ice cold water and not just a normal room temperature water? Because if the compound actually precipitates in cold water, so that shows that this complex does not dissolve in cold water. So we can use cold water to rinse off whatever impurities present in the sample. This solid will be dry in a vacuum desiccator over anhydrous calcium sulfate. Now we have our sample ready to dry in the vacuum desiccator for about 1 hour. This is the purification step where the dark solid, manganese 3 acetylacetonate, after drying in the vacuum desiccator, will be dissolved in around 20 ml of toluene, and this solution will be warm. Okay, so after the solution is warmed, we'll filter and cool in ice bath to obtain the crystals. So along with that, we also have another flask of warm toluene. We prepare this for rinsing purpose. Okay, so just rinse the filter paper a bit with hot toluene. Filter our sample while it's still warm. Rinse the flask so that all compounds will be filtered as much as you can. Also rinse the filter paper with warm toluene. But before we proceed to filtration, add around 75 ml of petroleum ether into the cold solution to enhance the precipitation. So the purpose of adding petroleum ether is to enhance precipitation. So this is what we got, and don't forget to rinse a bit with petroleum ether and let it dry for a while before we store this in the vacuum desiccator. So today I'm going to demonstrate on how to use the equivalence. So first of all, what you need to do is to get the weight of the empty sample tube. This is how the sample tube looks like, right? So get the weight first. Zero point 0.8342 grams. then we press stir on the Sherwood scientific meter. Okay, press stir till you get a 0 and insert your sample tube into the balance and press range to give you 10 to the minus 5 V. And after that, you have to press stir once more. Okay. Now remember, this is the compound that we have prepared yesterday, manganese 3 acetylacetonate. And by using a small thin spatula, we're going to insert this sample into the sample tube. So the amount of sample that we are going to insert in the tube should be a minimum of 37 millimeter height. Insert the sample slowly and tap a bit so that the sample is all completely packed. So the sample is now completely packed up, and the height is around 37 millimeter. Yes, 37 millimeter. We have to weigh the tube with the sample to get the weight of the sample. This is what we do. Tear. The sample and get the weight 0.99. And after that, you need to calculate the weight of the sample. So the weight of the sample is 0.1568. Now put the sample tube into the balance. Okay. And we press length. Well, when we press length, the height of the sample is 37 millimeter. 370 millimeter. The weight of the sample, we press weight. Okay, by pressing weight, you have to insert the weight of the sample. So the sample weight is 0.1568 gram. And then we press magnetic susceptibility. So the magnetic susceptibility value for this compound is 0.280 times 10 to the minus 4 M. And don't forget to also check the temperature of the surrounding, okay, because the temperature will be included in the calculation.